I'm Maddie. I'm the program manager of the QuickSight Learning Series, and I just want to say first off, thank you so much for coming to 2025's first session. Happy New Year to everyone. Today's a really exciting session. We're going to be covering scenarios with Amazon Q and Amazon QuickSight using an education industry demo. So what the agenda for today will look like, I'm going to just briefly cover the capabilities with scenarios and how we released it at reInvent. I really just want to focus in on the demo today. So I'll do a demo background and then dive into the product. We'll go end to end about what this can look like and how you can use scenarios. And then I'll just briefly cover some learning resources. So what is Scenarios by Amazon Q and QuickSight? So Scenarios was released in reInvent in November, and this is our product for Amazon Q and QuickSight users, where it allows you to simplify complex data analysis tasks for any business users. So what that means is this is an agentic scenario analysis. So we like to say that this guides you through a complex data analysis, which is different from our previous Amazon Q offerings. Before you were able to answer simple questions with natural language, but now you can dive into deep business problems, and scenarios will take you through a step-by-step about how to tackle that problem, different calculations it's using to solve your problem, what type of visuals it will correspond to the different answers it's giving you through the steps, and then give you some final recommendations in order to solve a complex business problem. And we like to say that this is purpose-built for BI. Scenarios allows you to automate your workflows and be able to eliminate a lot of the manual work that comes with multi-model turn-based AI analysis. So say I am a business user. Previously, before scenarios, I might have had to say, go to a data scientist, my analyst, or something similar in order to find these answers within my data if I didn't understand. But now with scenarios, I'm able to at least take on more of the workload for myself in an easy fashion, and all in one simplified, unified environment within QuickSight to be able to get these answers for myself and save time for my other employees. And the other thing about scenarios is it's reusable and extensible. So say you have a scenario that you finished up and you want to see it in the future, you'll be able to find it in your homepage within Amazon QuickSight to return to it. And if you want to add or change any parts of your scenario, you're able to do that as well. All right. So that was just a brief high-level view of scenarios. Again, I wanted to keep it brief so I can get right into the demo. I think the most powerful thing about this tool is being able to see it in action. So we're going to go ahead and do that now. Before I'm just going to go over the use case background. Okay, so here is our use case background. This is an example of a university called Any University. They are a public higher education institution, and they have students enrolled from all over the country, and we're using United States. Currently, they use Amazon QuickSight to visualize student performance using demographic data in order to measure their overall performance as a university. And their administration is interested in understanding how they can attract more high-performing students, analyzing their test scores and different factors of demographic data. All right, and so now we have that background covered. We'll keep that in mind as we go through this demo. Again, if you have any questions during this demo, please ask in chat. We do have two moderators, Jill and Roy, who will be moderating throughout this demo. So I just want to call that out. All right, and then let me go ahead and just switch my screen here. Okay. All right, so here is my dashboard that any university has created with all of our performance metrics. You see here we have two tabs at the top. So our first sheet is this performance indicators, which I'm currently on. And then the next is major indicators, which are the different subjects that students are taking. So I'm just going to briefly go over the different visuals that we have in our dashboards. Here we see the different majors by state in the United States, how different grades are declaring their major, so the popularity based on what grade they're in. And then test scores of parent education. We see this chart that shows majors chosen by gender. A few more charts here. This horizontal bar chart showing test scores by subject. And then a grade distribution of what major they're in and what grade they achieved in that major. Right. So we'll go through this here, and you can kind of see that computer science is making a bigger bulk of this proportion, which might make sense in today's society. And again, I just want to call out, this is fictitious data. We wanted to use this for anonymity. So this is fictitious data. This isn't real. This is just for purely demo purposes. Okay, and then to performance indicators here. So this one here, this pie chart is showing different racial groups, which we've anonymously labeled from A through E. And lunch, if that might sound confusing, we use lunch here as a socioeconomic indicator to determine if, one, they're on lunch any programs or if they bring their own lunch. And then we have this graph here that's showing the test scores by racial identity, and you can see a big call out with the C and D group having much higher test scores than the others. And then again, some more average test score data. And now we'll just dive into scenarios. So there on the build button, you can see we enter this scenarios environment. And say I want to ask a question on my data. Maybe I want to ask something about how the demographic data is corresponding to test performance and if it's a significant indicator. So I want to ask something like, what relationships between student, let's say demographics, and test scores are significant? And I'm using that word significant to try to pull out any statistical data. Okay, and so now I'll just choose the different visuals that I want included for Q's analysis. And you can see here, I'm clicking visuals from my dashboard. And then on the left pane, while I'm clicking these visuals, you'll see that I'm able to actually go through my other dashboards as well to choose visuals from those. So I don't have to just choose visuals from this one dashboard. I can go in between sheets like I'm doing now, or I can also choose different visuals from other dashboards. All right, so I think this is about all that I want to click. And it's going to preview all of my data that I've chosen. So these are just all the fields that are included with those visuals. And now Q is just loading up those data sets for it to begin its agentic approach. All right, and then if you see there also in the upload file, since we're already here, you can actually upload files from your desktop as well. So if you had data sets or want data sets uploaded from like a data scientist or a BI engineer that you then want to add to your data approach or your scenarios approach, you can do that as well using upload. Okay, so I press start analysis, and now what Q is doing is giving me suggestions based on my data sets, the visuals I chose, and my prompt to give me a few suggestions of where it thinks I should begin if I don't already know what to do with my data. And then you can see as well there, it says describe what you want to analyze next. I don't have to choose a suggestion Q provides. I can actually type my own if I wanted. But I'm going to choose a suggestion just so we can see what that looks like. So here you can see it gave me 5 suggestions. And there's some really good ones here. I see average test scores for males across different majors. But let's choose this gender one. And then we'll just wait for Q to load this up. But in the background, what it's doing is analyzing our data set, our prompt, and then this suggestion to pull out anything it thinks it's significant within our data sets. Okay, great. So it's loaded up our first step. It says, we see female students have a slightly higher average test score compared to male students. So to me, this doesn't really look very significant. They're pretty much the same, but that's an interesting call out. And now let's see if I can do a different factor and see if that is a bit more significant. And what I'm doing now is going down a different thread. So we call this going down parallel threads. And this allows me to do 2 analysis of different fields at once. And so here I'm choosing to go down this gender thread to see if I can uncover more, while Q is also loading its thread down for the different parent level of education, just so I can be able to quickly automate those things at the same time, and save time in the future. And this also allows me to just do a side-by-side comparison, comparing level of education and gender with each other. So let's see what that results in. And I can see for level of education, it's already prepared at step 1. And then let's just wait for it to prepare more. All right, cool. Okay, so let's go dive into. All right, so I've chosen one of the other suggestions about how does parental level of education affect their math and reading scores. We see this step 1 here, and we see this really interesting call out that some high school education shows the highest average test scores here, which we wouldn't have expected. And we see actually the lowest was with parents who have master's degrees. And again, this is fictitious data, so this is probably why. But that's a really interesting call out from a real world perspective because we wouldn't have expected that at all. And then now it's generated this step 2, actually creating visuals from this data set. So we see the visuals it's created here, much higher scores for reading than for math. And then again, it's showing more of the filtering of this data. And we can see here where it says average math score, average reading score for level of education. Q in the background has made that calculation on its own. That wasn't in the original data set, and it's inserted that into a new data set that it created. So that's pretty cool. All right, and then we have this step 3. So now we're getting into the most interesting part is conducting statistical tests, which is great because I did have that word there. I want to find things that were significant. So Q knew to conduct these statistical tests now to see if any of these are actually significant, to see measuring how strongly the level of education is related to test scores. And we see here it says it shows a higher F statistic for math scores compared to reading, suggesting more variation in math scores across levels of education. But the correlation is negative and slightly low for both math and reading, showing very weak. So that's interesting. If I'm a business user, maybe I don't know what an F statistic is, what that means, or an ANOVA, which I see here, it says in the data set. But it's interesting that I can see that and it gives me an explanation of what that means at a high level. And I could send this to my data scientist then for them to dive into deeper. So it just saves a little bit of time for me and my data scientist or data analyst. And it's an interesting call out that Q has made. All right. Okay, so that was an interesting step 3 that we have here. Okay, so looking at these, I see also parental level of education affecting science and writing scores. We see some interesting ones on lunch status, but instead I'm going to choose, let's do that first one there, just because at first we did math and reading, and the other 2 subjects were science and writing. So we'll see if any of those are significant as well. Okay, and then while that's loading up, let's return back to gender, and we'll see what this came up with. So what are the average reading for the average test scores for all genders? We can see that females actually score slightly better in most cases, but it's not really telling me anything statistically significant. So I'm actually going to just keep going down and see if I can pull out some more data with recommendations. Okay, so this is the capability that I'm going to test out for describing my own questions. Thus far, I've just been using the suggestions it's giving me, but I want to show you how you can ask your own questions using scenarios. So now I want to see and actually ask it straight up is if there's any statistical significance between gender and test score. And let's see what it says there. While that's happening, again, I'm switching back and forth doing these side-by-side comparisons, and we'll see what this has told us here. So for level of education for science and writing, again, interesting callouts. We see that high school education is actually scoring much higher, or not much higher, but higher averages than master's degrees and associate's degrees. But we also see bachelor's degrees is second highest average scores. So again, fictitious data, but that's an interesting call out if I was in administration. And then the step two here, again, creating a visual to just better understand visually what my data is looking like. So we can see comparisons across the board. They all look really similar again, which is why I want to see that statistical data run its tests because I might not be able to see if this is actually significant or not based on this visual or the data set. All right, and then we see below here, again, just a final filter of the data and what that looks like. And again, with our, we can see it's still loading up, but it's doing that meat of the work of actually running the statistical tests in the background and using models to give me some insights. All right. Okay, so I see in this explanation, it's showing that the analysis shows weak correlations between parental education level and both science and writing scores. The ANOVA-like F statistic for writing scores, 3.3, is higher than for science scores, 1.1, suggesting more variation in writing scores across parental education levels. So again, if I was a business user at the surface, maybe I don't really understand what this language means and what these numbers represent. But to know that I already have this ran for me and can just send this straight to my data analyst to review further is really powerful. So again, we have this chart here that's showing all those values. And if I don't know, again, maybe I could do a search on my own, but I could just send them a screenshot or share this scenario with them, and they're able to dive into that deeper. And here, this is the actual interesting part, is this step 4. It's pulling out an overview of all the insights we've gathered from the beginning of the thread. So it's even including the science rules for all parental education, science, and writing. And then it's also showing here the trends. So we see here it says there is no clear linear relationship between parental education level and student performance in science or writing. Differences in average scores are relatively small, suggesting other factors might be more significant. Great. Then it's giving me again that overview of statistical analysis. And then this final part here where it says this conclusion. So we see, while there are some differences in average scores, these differences are small and do not follow a clear pattern. The weak correlations suggest that parental education level alone is not a strong predictor of student performance in science and writing. Other factors, such as individual student characteristics and other things like socioeconomic factors, might play a bigger role. So that's great. That kind of rules that out for me to want to study that any further. And now I'm going back to gender here. So again, this step 1 is immediately doing that statistical test and want to call out again, it's doing all these calculations and modeling in the background. We see that it's having in this table the subject for each one, the T-stat, F-stat, and the correlation, the Cohen's d, and a visualization representation of what that looks like. Okay, so that's pretty interesting. I think I don't understand that as a business user, but maybe I'll send that to my data scientist to review further. And I just want to emphasize the point of although scenarios is this approach that's trying to be agentic, what we're really trying to do is continue to keep that human in the loop interaction with your data scientists and data analysts and BI engineers. So it's giving you these answers, but we always like to say keep a human in the loop to not just fully rely on scenarios, but it's just helping you be that buddy for you to give you the answers that you might not have seen in your data. Okay, and then now I'm going down to this new thread here. So I've already analyzed gender, I've analyzed level of education, but now I want to dive into something deeper. I want to look at socioeconomic data. And here, I'm just trying to understand like what different socioeconomic factors are relevant. Okay. And again, this is just going down another parallel thread. So I can be able to make that side-by-side comparison with gender and level of education with parents. All right, and we'll just wait for Amazon Q to load up this scenario. Okay, so step 1. It says we'll start by identifying the socioeconomic factors available in our data sets. That's great. So it's showing the different ones that I think it might be eligible. So it says state, course cost, which is interesting, education, which we've analyzed, and then lunch program eligibility. All right, and then now it says socioeconomic factors appear to be relevant to student test performance. Students with parents who have some high school education tend to have higher average test scores, which we've already seen. And there's a slight positive correlation between course costs and test scores. Okay, that makes sense, and that's an interesting call out. Additionally, performance varies across different states. That makes sense as well. And we see here two data sets that are giving me the breakdown of this information. So here I see the lunch, and then some visuals that are corresponding to that. Again, costs for course with the data set, and then another visual that's corresponding to that as well. Again, these all look pretty similar across the board, but maybe I want to see if there's anything statistical significant there because face value, it all looks very similar. And then lastly, it's giving by state here. Again, it's also looking very similar. So now let's dive in deeper. All right, now I'm just kind of looking through these suggestions to see if there's anything interesting. But let's continue to ask around. So I want to ask something like, are these relationships statistically significant? Again, just because a lot of the data looks really similar. And then Q will begin analyzing this step by step. All right, and we already see it's beginning with step one. So it says, we'll start by preparing our data, including creating an overall performance score for students. So that's great. It's then concatenizing the data to be able for me to understand and filtering from my huge data set that I already had. Okay, and we see it's doing this analysis here. All right, based on the statistical test performed, lunch status shows a significant relationship. That's awesome for me to understand. And then other relationships like level of education, course costs, and state don't appear to be statistically significant, giving the low F-stats and correlation coefficient. All right, that's pretty interesting. Okay, and then we see here that once again, Q is doing the calculations in the background and then creating these new data tables. So I'm able to just briefly see all this data in one place here, showing it by gender, major, test score, evaluation score, course grade, and then the different scores. All right, and this one, it didn't show me anything with visuals. So I think I want to just keep on diving deeper into this thread and be able to uncover more information. But again, here you can see that I can continue side-by-side comparisons and even modify this thread if I didn't like the output. So it tells me what variables it's been observing, and I'm able to type in there if I wanted any changes I wanted to this thread to improve my answers that Q was giving me. All right. Okay, and then I'm just quickly glancing over all of this. I want to see where else I can uncover some more insights. And I think I'm just going to keep on going down the thread we've been doing. So this one looks interesting, is lunch status. We noticed that that was one of the only factors that Q thought was significant. And then this one as well was test scores against cost per course. But that's interesting, is how would test scores change if all students took a test prep course, regardless of socioeconomic status? So that's a really interesting suggestion that maybe I wouldn't have thought of to ask Amazon Q. And for it to suggest that, I want to see where this goes. So this is something you can do in your scenario if not you necessarily don't know what you're looking for. Q brings up these suggestions that are interesting, and maybe I want to dive deeper. And again, I don't have to keep this thread. I could delete it if I wanted to, but let's just go down this rabbit hole and see what it comes up with. All right. Okay, so we see this step one. It's already loading up here. We'll start by comparing the average test scores of students who took a test prep scores or took a test prep course with those who didn't. Okay, that's great. So I can kind of see where the logic is coming from Q, being able to dissect the data and interpreting this step by step of where we need to start and where we're going. Okay, so still analyzing, but this is a pretty loaded question, so understandable. All right. Okay. So students who took the test prep course showed improvements in most subjects, with math scores increasing 3.3%, total score improving by 1.3. But less than 40% of students took test prep courses. So maybe that's not a great indicator of my whole sample data. But it's interesting to see these little improvements here within each subject and total score. And again, all this data is looking kind of similar between with test prep and without. But let's see what this step 2 picks up. Okay, we can see it's still loading there. But if we just look at it, we'll check if the difference in test scores between these two groups is statistically significant. That's great. And estimate how much test scores might improve if all students took the test prep course. And we'll just wait a little bit to see what it shows in its analysis. Okay, great. So we see that it's led to a statistically significant improvement in total scores. On average, people who took the course scored 3.6 points higher, which doesn't seem a lot higher, but interesting that it is statistically significant. And then again, we see some of that data set in that, or some of that data put into a table with the calculations cues made in the background and a visual showing the differences in numbers. And now it's moving on to its step 3. We'll examine and visualize how the test preparation course affects students from different socioeconomic backgrounds. All right, that's interesting too. Now we're looking at a different part of the problem. And we can see here it's beginning to load up the response that it's given and the data set that it's providing. So we see that the test prep course improves scores across all socioeconomic groups. That's awesome, with improvements ranging from 0.4% to 2.5%. Right? And then it says that students who are holding bachelor's degrees showed the highest improvement, while those with some high school education showed the least. Overall, the course led to a 1.4% improvement in total scores. Okay, that's interesting too. We also see this lunch variable put in here again. And then corresponding visuals that it's provided. Great, so we see a pretty significant difference here compared to each one. And then a little bit similarly to lunch. All right, here we go. And this is our step 4. So again, it's giving me the 5 overall trends that were shown in my data with a really in-depth description of each one. So we see here it's showing 1 for overall impact. And then we have another for 2, socioeconomic variation, 3, potential impact of universal implications or implementation, really interesting. 4, educational equity, interesting as well. And then 5, practical considerations. And then I'm kind of just briefly glancing at all this data that it's given. So we see the lunch one is slightly higher improvement compared to those who are not eligible. Test course preparations, the impact will likely vary across socioeconomic groups. And then educational equity, which is really interesting. I didn't start this scenario at all thinking about educational equity, but I think that's a really good call out to make. And then practical considerations, universally may be limited. Cost effectiveness, such as implementation, should be carefully considered against other potential interventions. All right, so here in this conclusion, I want to make some callouts, which is really interesting. Oh, sorry. Go back here. I want to make some really interesting callouts is that while the test preparation course does not show a statistically significant positive impact on student performance, Its effectiveness varies across socioeconomic groups, which we can see with our data. Universal implementation might slightly improve overall scores, but could potentially widen some existing performance gaps. Educational policymakers should consider these findings alongside other factors, such as cost, alternative interventions, and specific local needs when deciding on the best approach to improve student performance and educational equity. So that's great. It's using its real-world knowledge from our large language models to put this into our conclusion. And I think that's a really interesting call out to make. It's not giving me a very precise recommendation in terms of exactly what I should do, but leading me down that road of getting me to think about these things, about educational equity. What type of policies can we make to be able to, with this data, make the right decisions for our university? And I think that's one of the most powerful things about Q is it's giving you that hand-by-hand support to lead you through the areas that you might not have known existed. Okay, so that covers the end-to-end with this demo.